Hello there. Today we'll be doing search rotated sorted array. So in this problem, it is our 49th problem. Hopefully we'll get to 50 today. In this problem, we are given a sorted array, but it's rotated, so it's out of order. And we have to find the target within O of log n. And yeah, so that basically leaves us with binary search. So binary search, very simple. L and R, you set it to the 0 and the length of the nums -1. Then we're going to try to eliminate the options. So the unique point here is that this left side is increasing and the right side is increasing, but we don't know where the middle part is. But do we really need to know where the middle part is? We just need to know whether it's increasing or not, well, which side we're on. So what does that mean? So while left is less than equal to right, we're gonna keep eliminating items, and we're gonna start eliminating items from the middle, like any other like binary search problem. So if the nums of middle is equal to target, return the middle, and we're done. Otherwise, if we don't find anything, return -1. So, but what are the steps to finding out more information about what our middle item tells us? What the middle item tells us is that if the middle item is greater than the left item, that means we're in increasing order in this slot. If our target is between the last and the middle item, then it's in between these items. Otherwise, we're in this particular section, or this section, or this section. Doesn't matter which one. We're in a section where we are. So left is not greater than the max. So like let's say we're 0 or 1 or something, right? That means we're starting at M all the way to R. We're increasing. Either way, we're increasing from one side to the next side. So if nums L is less than or equal to nums M, then we are doing increasing order from L to M. Otherwise, what happens is L is greater than M, but M is less than R. It must be the case. We're always going to be in order. So yeah, a simple way to think about this is, well, if we're in order between L and M, so if nums L is less than or equal to a target, and nums M is less than the target, the target is less than M, that means it's in between these items. And if that's the case, we can just simply place it in there. Like we can just go like, well, R equals M -1. It must be inside this item, or it's not. It's outside these items, so M + 1. Otherwise, we have the situation where it's M is less than R. So basically, that means if nums R is less than or equal to, or is greater than or equal to target. No. Yes, greater than or equal to the target, and the target is greater than or equal to nums M. So if the target is greater than M, but less than the R, so if I flip this around, I think it'll be a little bit more. It's greater than, this can't be equal to M, it's just not possible. But if it's greater than or equal to R, then it must, I mean nums are, then it must be in the between those m and r, so L equals m plus 1. Otherwise, it's not in between those, so r equals m minus 1. So with that, I think we're done. Let's run the code. Some problem here. No. Alright, submit. Okay, we have a problem. Looks like we didn't find something. Okay, let's take a look again. What's going on? So, less than or equal to. It's greater than or equal to. No, it's less than. Has to be less than. Let's see, and the R part, its target is less than or equal to. What the heck am I doing? Has to be less than or equal to. Run the code again. Weird. What did I do wrong here? Target is less than or equal to NMR. Makes sense. Target is greater than num. Yeah, makes sense. Num was greater than target. No, that doesn't make sense. It's less than or equal to target. That makes more sense. There we go. There we go. There we go. Perfect. So right. We just need to make sure that the target is in between L and R, or in between R and M. If it's in between them, then let's search the inside that point. If it's outside of that point, it must be on the other side. It must be outside of that. So we searched that particular portion. Another explanation, maybe a more clear explanation, one that Neetcode has, is that we're going to use an OR operation. So let's, oh shoot. Right, so let's use an OR operation. And let's do this. So I think this is let's just organize this a little bit better though first. Let me just organize this code so that we can get a better sense of what's going on. So, all right. I just think that I was writing the code a little bit more mistakenly. I think if we did this instead, it would make more sense. If the target is in between M, right, and less than R, there we go. If the target is greater than L and less than M, run the code. Better, better, better. This is much better. Okay, so I think that makes much more logic at this point. But let's run this code again using an OR statement that we learned from Neetcode. And this might make a more intuitive sense or less intuitive sense. But I mean, if there's another way to think about it, let's think about it. Let's see what it is that we have to, what we can think and what we can do, and what maybe intuitions that we can share. So if, again, we're going to do this in increasing order, if we know that it is, the left side is going to be like less than the middle, so we're going to go in increasing order from the left to middle. So let's check that. So if the item is going to be, let's say, the target is greater than M, right? If its target is greater than nums M, what does that mean? That means it cannot be in this section. That means L plus equals 1. equals m plus 1. Why? Because the target is greater than m and everything below m is less. Another reason to not check the m is target is less than num's L. Then L equals m plus 1. So what are we eliminating here? What we're eliminating here is that, okay, well, we're limiting this particular L through m spot. What we're trying to eliminate is, is it a number greater than m? Is it a number less than L? If it is any of these two, then it can't be in L through m, and we're going to remove it. So increasing order from L to m, we are going to see if target is outside of range. So the difference between my method earlier and this method currently is that I was checking if it was in range, and this particular method is checking if it's outside of the range. So basically, this basically means this target is less than nums of L, so it's outside of range. Otherwise, it's in range. Otherwise, it must be in range. So R equals m minus 1. And the same goes for this other side, where we're increasing order from m through R, right? And we are going to see if the target is outside of this range. So let's check if it's outside of this range. So if the target, let's say it's greater than R, so greater than nums R. If it's greater than nums R, then that means that we are outside of the range of R. Else, then that means if we're outside of this range, let's remove this. Let's R equals m minus 1. Else if, let's say the target is less than m, right? If it's less than m, then it can't be in this range either. So R equals m minus 1. So that means we can put these two together, say, oh, this is what it means to be outside of this range. If we are outside of this range, let's remove it from our range. And otherwise, it is in our range, so m plus 1. And that is how we do it the Neetcode way as well. So it's inside the range, outside the range. I think they're both good ways to solve the problem. So I'm really glad that we went through both ways, inside the range and outside the range, and went through that logic, because it really solidifies the idea of how we can remove the options that we have. Again, it's about removing the number of options that we have using binary search. In this sense, it's removing the options to see if the target's outside of this range, and for my method, it's if target's inside the range, and that means we can exclude the outside. And this one means we can exclude the inside. So this is very good. I'm really happy we went through both methods. I think we learned something today. And if you enjoyed the video, like and subscribe. If you have any questions, comment below. And if you want more videos, check the link in the description below. And thank you very much for watching. I'll see you next time.